in yesterday's lecture, we have discussed about alkyl halide, okay, and we have also discussed about the type of reaction that alkyl halide can undergo, okay. So basically, in general, alkyl halide can undergo two types of reaction, which are the first one is elimination reaction, or also known as dehydrohalogenation. Basically, it is a removal of hydrogen and also halogen into forming alkenes as the product. And then secondly, we have nucleophilic substitution reaction, which the halogen will be replaced to will be replaced with another nucleophile, another powerful ataupun stronger nucleophile. Okay, all right. You have been introduced to alpha and beta carbon. Okay, alpha and beta carbon. So alpha carbon is a carbon that bears the halogen, carbon that is directly attached to the halogen, whereas the beta carbon is the carbon that is adjacent to alpha carbon, which is located exactly next to the alpha carbon. Okay, all right. And then, so we start with elimination. Okay, so you have to know that the reagent used in the elimination of alkyl halide. So we will be using the base. Okay, so the base, basically we use sodium hydroxide or KOH that need to be dissolved in alcohols. Okay, so it need to be dissolved in alcohol. So it is known as alcoholic base. Okay, for example, we have methanol as a solvent, and then we have KOH as the base. So when these two are reacted, it produces potassium methoxide. Okay, where you remain the oxygen, and then you attach with the metal. Okay, so O will bear the negative charge, whereas K is the metal will bear the positive charge. Okay, and other than that, we also can use third butanol as the solvent, and then we have KOH. So when these two are reacted, so it produces this alcoholic or potassium third butoxide. Okay, all right, and we also have sodium ethoxide. Sodium hydroxide can also be used in replacement of potassium hydroxide. Okay, so you will also been introduced to Z-ZEF rule. Okay, Z-ZEF rule is the rules that governs the formation of product form from elimination of alkyl halide. Okay, Z-ZEF rule is when you have options of beta hydrogen. Okay, so we like for example we have alpha. So alpha is the carbon that is attached to the halogen. Okay, so we have two carbons that are adjacent to this alpha carbon. So we have beta first, and another beta carbon, which also bears the hydrogen, the beta hydrogen. Okay, the beta hydrogen. So in this case, we have to take into consideration the most preferred hydrogen in order to be removed from this alkyl halide. Okay, yang paling maksudnya based on preference. So preference tu we need to be based on Z-ZEF rule. Okay, we need to be based on Z-ZEF rules. Okay. So based on Z-ZEF, it prefers to form alkenes that have more substituents. Okay, so the most highly substituted alkenes is the most stable one. So the less hydrogen it is in the molecules, okay, that is attached to the carbon, the less hydrogen, the better lah. Okay, so the lesser hydrogen we have the lesser hydrogen, the better. Senang cerita. Okay. Right, so we have major and minor. In that case, we have major and minor. So major usually follows the rules, whereas minor is the one that apa nama tu, opposite the rules. Okay, it will form as minor product. Okay. Okay, so we have checkpoint, this one. I leave this checkpoint for you guys to try out. Okay, so next, let's move on to the next type of reaction for alkyl halide that is known as nucleophilic substitution. Okay, all right. Okay, so basically nucleophilic substitution of alkyl halide, we want to substitute the halogen. Okay, we want to displace this halogen ataupun substitute ataupun replace this halogen with something else. Okay, so that something else is known as nucleophile. Other stronger nucleophile than the halogen. Okay, so the nucleophile displaces the leaving group. So the leaving group in this case will be the halogen. Halogen will be leaving the molecule. Okay, so this is a substitution reaction. Nucleophile substitutes for X. Okay, so two important nucleophilic substitution reaction are, so we have two types of nucleophilic substitution for alkyl halide. Okay, so the first one is known as Sn2. Okay, and then secondly, we have SN1. Okay, so the reason it is known as SN2 is because of it involves bimolecular reaction, bimolecular substitution nucleophilic reaction. Whereas SN1 stands for unimolecular substitution nucleophilic reaction. Unimolecular means one, uni. Bi, on the other hand, represent two. Okay, so we will look into these two reaction, okay, in detail in the later slides. Okay, so this is basically the general reaction of nucleophilic substitution. So we have alkyl halide. So this is our starting material. So we have nucleophile. Okay, nucleophile. So nucleophile will then replace the halogen. Okay, will then replace the halogen. And then there you go. So you have the nucleophile as the substitute, okay, to halogen. So halogen will be the leaving group. Okay, simple saja, dia nak replace saja. Okay, so we are going to discuss on SN2 first, okay, and then we will cover the SN1 later on. Okay, so SN2 nucleophilic substitution. Okay, so this is example. Okay, we have CH3Br. So this is alkyl halide. As you can see, this is methyl alkyl halide. Okay, methyl alkyl halide. This is not primary alkyl halide. This is methyl alkyl halide because the bromine, the halogen is directly attached to the carbon, and this carbon does not attach to any other carbon. So that's why it is not primary alkyl halide. Okay, hope you guys really understand this. Okay, and then this alkyl halide, methyl halide, react with sodium hydroxide in aqueous in reflux condition. Okay, you may Google how reflux looks like. Okay, so that is a condition that need to be prepared. Okay, for this reaction in order for this SN2 reaction to take place. So what actually happened is that OH, sodium hydroxide, actually supplies the OH. OH is the nucleophile. It supplies the OH minus. Okay, OH minus is the nucleophiles, which then will be added. Okay, will be substituted. Okay, will substitute the Br, the halogen. Okay, and becoming alcohol. So this is alcohol. Okay, and this will be the leaving group. Very simple. Nampak macam, oh, replace je lah OH minus, ganti dengan Br. Okay, so reaction rate, we were to recall our topic 1 last time. Okay, the kinetic topic. Okay, reaction rate is equal to rate of disappearance of reactant. Okay, so rate is equal to rate constant times concentration of CH3Br times concentration of OH minus. They are both raised to a power of 1. Okay, ini order 1, ini pun order 1. So 1 plus 1 is equal to 2. Is equal to 2. So that's why the SN2, it is bimolecular. Okay, so kinetically, the reaction is first order in each reactant for each reactant and second order for overall reaction. So that second order represent the Sn2 nucleophilic substitution. Okay, all right. So this is the mechanism. So this is quite popular mechanism for alkyl halide. Okay, so please take note. So the mechanism involves substitution of halogen with a nucleophile in a concerted, in a single step process. So this process is, this process proceed in single step. Maksudnya dia bukan like macam formation of carbocation last time dalam alkyne kan. So they form carbocation. And then next, the nucleophile attack the carbocation. So it proceed in 2 step. But this one, dia tak ada formation of carbocation or whatnot. They proceed terus. The other intermediate, as you can see, we have intermediate or transition state and then quickly form the final product. So that's why they kata single step. Maksudnya, even though the intermediate is formed, but it is very fast reaction. Very fast reaction. Because why? Transition state ataupun intermediate, they usually are very unstable. Bila tak stable, dia akan jadi sekejap saja. Okay, in very short period of time. Sebab dia tak stable. Bila tak stable, dia hanya akan jadi sekejap saja. Dia tak boleh tak jadi. Dia kena jadi. In order to form final product, it need to undergo that transition state. Without the transition state, the final product will not be formed. Okay, tapi dia hanya terjadi sebentar sahaja. Okay, contoh. Look at the mechanism. Okay, alright. Okay, so this is the methyl bromide. So this is the methyl halide lah, basically. Okay, so this is the structure. Okay, so the OH that come from sodium hydroxide just now. Okay, so sodium hydroxide supplies the OH minus. This is the nucleophile, the one that will be involved in the reaction. Okay, right. So the OH minus will attack, nucleophile attack kan? So the hydroxide ion will attack the carbon. Okay, so it will attack the carbon from behind, ataupun the opposite side of halogen. Dia ada reason kenapa dia attack dari belakang ni, bukan just simply based on just simply drawing aja macam ni. Dia mesti attack from behind, from opposite side of bromine. Okay, from opposite side of bromine. Why is that so? So saya cerita dulu. Nanti dekat slide dia ada cerita, dia ada reason dia lah, justification dia. Tapi saya beritahu awak dulu so that kita ulang lagi nanti, you get a better understanding. Okay, on how the reaction ataupun the mechanism takes place. Okay, so OH minus will attack from the opposite side of the halogen. Okay, kenapa? Because it is easier. Because why? Bromine ni, it is electronegative. Okay, bromine is electronegative. Even though it is not as electronegative as OH minus, but the cloud of electron is already, very intense lah dekat situ. Sebab dia cloud of electron kan. So OH pula pun electron, very negative. So bila negative dengan negative, they tend to repel. Okay, so so the best is to attack from somewhere yang less hindered. We call it hindered ataupun less of negative charge lah. Okay, so kat kawasan ni, dia punya the negative surrounding tu is very, very intense. Okay, so it will be harder to attack from the same side of the halogen. Nak attack daripada, saya nak buat dia melengkung. Okay, nak attack here nak attack the carbon here is very difficult. Okay, very difficult. It will be hindered by this bromine. Okay, all right. So it will be difficult. Therefore, the best is to attack from the opposite side. And after all, walaupun dia ada atom-atom lain, so as you know, every atom has its own cloud of electron. Okay, so this is only hydrogen. Okay, we know that hydrogen has only at most pun dia boleh has 2 electrons. Okay, so ataupun dia 1 ataupun kosong kan. So this hydrogen does not, this hydrogen do not to have that much of hindered effect on the nucleophile. Dia tidaklah menyusahkan. Dia ada dekat situ, tapi dia macam very mild lah. Dia punya dia punya electron density dekat situ. Okay, taklah menyusahkan. Okay, so that's why they attack from behind. Okay, so bila dia attack from behind and attach itself, so maksudnya dekat sini, you kena ada apa? This arrow, satu saja arrow. Attack from the opposite side of bromine, of halogen. Okay, guys? Okay, so proceed, arrow, and then as you can see, this is what we call transition state, as what we have learned so far. Okay, so transition state is the condition ataupun a state where the species is very unstable. Okay, because kenapa dia unstable? Because carbon now has 5 bonds. Carbon has 5 bonds, but 2 of the bonds are about to be broken and formed. Okay, that's why the transition state, they're very unstable. Okay, all right, so you can represent the instability of this transition state by using dashes line. Okay, dashes line for OH, dashes line for bromine. Okay, so this one is about to break. This one is about to form sebenarnya. So kena represent using dashes line. Okay, later on, you kena ada this arrow mechanism kan. You have this arrow, full headed arrow. It shows that this bond will be broken down and the 2 electron will be given to bromine and becoming bromide ion. And there you go for your final product. Okay, ada OH sahaja dekat sini. So this OH dah substitute the bromine just now. Okay, the bromine just now. Okay, and as you can see, saya delete sebab nak bagi nampak sikit. Okay, as you can see, initially nampak tak dia macam payung. Initially dia menghadap sini kan. Dia facing this side, facing to the left. But once OH has been added, okay, dia akan ke tengah sebab dua-dua ni ada bromine and OH. And once bromine has leave the group, leaving behind the OH, nampak tak? Dia flip to the other side. Flip to the right side. Dia macam payung lah kalau angin kuat kan, dia boleh ternaik kan, terangkat kan, macam tu. That is what we call Walden inversion. Because why? Again, the density of electron for OH, the electronegativity of OH is very powerful and it causes the penolakan. Okay, it pushes the hydrogen to the opposite side. Initially, dia menghadap sini. So after the addition of OH, after the substitution of OH, the H is now facing to the opposite side. Okay? So inilah ceritanya. So it's best for you to use 3D form, okay, to represent this nucleophilic substitution. Okay? Right. The steric effect, this is the one that I mentioned to you just now. Okay, kenapa dia prefers to attack from behind, and then in fact ada reason juga, justification. Okay, the cause of steric itself. Okay, so the steric effect in Sn2 nucleophilic substitution. So the more alkyl group connected to the reacting carbon, the slower the reaction. Okay, so maksudnya Sn2 ni ada preference. Okay, Sn2 prefers methyl halide and primary halide rather than tertiary and secondary. Sebab apa? Sebab dia tak form carbocation. Kalau dia form carbocation, of course dia akan prefer tertiary or secondary. Primarily dia prefer tertiary lah. Okay, tapi dia tidak ada formation of carbocation. In that case, dia prefer, that is why primary dengan methyl halide are more preferable. Okay, kenapa? Okay, again, kenapa? Kenapa dia prefer primary ataupun methyl halide more than tertiary and secondary? Okay, so dia punya reactivity increases kalau methyl halide or primary halide are used. Okay, remember steric hindrance. Steric hindrance tu awan-awan elektron, cloud of elektron tu mengganggu kemasukan sebab dia macam bulky kan. Okay, steric. Okay, dia macam bulky, sempit dekat kawasan tu. So it would be harder for the nucleophile to penetrate into the molecule and attach itself to the carbon. Susah. Okay, so kalau kawasan ni memang dah susah. Memang dia tak boleh attack dari depan sebab this is already to dia punya the cloud of electron is very intense. So dia boleh attack daripada belakang. So kalau dia attack daripada belakang, kita kena make sure that dekat kawasan opposite side tu bukanlah orang-orang yang bulky. Because kalau group tu bulky, for example, kalau you ada CH3 kan. CH3 tu group bulky group. Maksudnya the more bulkier the group, it will be harder for the penetration of the OH. That penetration of the nucleophile. So kalau you ada hydrogen, so it will be easy lah for the OH to attack ataupun to attach itself to the carbon. Kalau you dah start ada satu CH3, ini dah makin lama makin susah. Makin susah nak masuk kepada carbon. Tapi still easy lah compared to kalau you secondary. Makin lama makin sempit laluan tu. Okay, for the penetration of the nucleophile to be attached to the carbon. And imagine if you have 3 more groups that even bulkier. Ini pun CH3. Kalau you ada ethyl, kalau you ada isopropyl, okay, so even bulkier group, so it will be very hard to penetrate. So that's why Sn2 prefers methyl halide dengan primary rather than secondary and tertiary. Okay, so nampak tak? Sn2 proceed faster with methyl halide. Sn2 proceed slower than bromoethane. Bromoethane slower than bromoethane. So this is bromoethane. Bromomethane ni, not bromoethane. Okay. Sn2 proceed slower than, sebab dia compare kan, slower than this one lah. Slower than this one. Okay, please replace this one with bromomethane. Bromomethane. Okay guys. Bromomethane. So dia lebih slower than the methyl halide just now. Ni nama dia apa? Bromomethane. Okay. So primary and then secondary. So this one even slower lah. And kalau tertiary, there's no reaction at all. Sebab susah nak penetrate. Okay. The carbon will be totally hindered. Tak boleh nak masuk lah semua. Okay. So kena ingat. Sn2 prefers primary ataupun methyl halide. Sebab SN1 later dia terbalik. Dia prefers tertiary. Okay, alright. So the alkyl halide is heated under reflux. So as I mentioned to you just now, so the condition need to be in reflux form with aqueous hydroxide ion. You can use sodium hydroxide, okay, OH, basically to supply the OH lah. Okay, so the OH act as a nucleophile, replacing the halogen atom to form an alcohol. So these are the reagent and condition. Okay, so you must take note yang kalau untuk SN2, dia mesti dalam keadaan aqueous and also in reflux form. Okay, alright. So senang saja kalau dia tak tanya mechanism, dia just tanya what will be the product form. You just replace the halogen with OH. That's all. Siap dah you punya jawapan. And this is the byproduct form sebab you will be leaving the group. Okay, same goes to this one. OH ganti with I. Siap. This one also Cl replace with OH. Macam pelik je ni. Kalau kita draw balik kan. Cl, CH3, and wish. CH2 is it? Cl, ni dah penuh ni. CH2. Ini unlikely ni. Ini macam tak berlaku je reaction ni. Okay, sebab apa ni tertiary ni? Okay, this is tertiary carbon, right? 1, 2, another one here. Tertiary ni. Okay, alright, so let's KIV this one. Okay, maintain this one. KIV this one. Okay, so sebab ni tertiary. Sebab based on this slide, dia kata tertiary is not very rare lah to take place. Kalau boleh pun mungkin we have to support with something. So this is tertiary. Kalau you tak percaya, cuba you draw this one. This is primary. This is methyl. Okay. 1, 2. Tertiary lah ni. Okay. Right, tak apa. Just contoh saja. Okay. Conversion. This is conversion of alkyl halide to alcohol. That means we are using OH as our nucleophile. Sebab kita nak convert into alcohol. Another one, we can also convert the alkyl halide by using nitrile. Okay, by using Cn as our nucleophile. Okay, Cn minus. So this can also be our nucleophile. So when we use Cn minus as our nucleophile, it provides a higher carbon chain. Kenapa? Sebab kita supply satu carbon lagi. Okay, it provides a higher carbon chain by adding one carbon atom to alkyl halide. Sebab kita we supply another carbon to the molecule. Okay, initially macam biasa, this is methyl bromide. Okay, so this one will be out. Okay, will be removed later on. So KCN will supply the Cn lah. Cn minus, which is the nucleophile, it will replace the halogen. So as you can see, initially kita ada satu carbon saja. Now kita dah ada 2 carbon. So dia memanjangkan rantai lah. Okay, it elongates the chain. Okay, memanjangkan rantai. Itu dia akan provide a higher carbon chain. Same goes to this one. So I minus will be going out. Okay, will be removed. So Cn minus later will attach itself to the CH2. To the molecule lah. Okay, so initially we have only 2 carbon. Now they become 1, 2, 3. So we have 3 carbons. Okay, alright. This one.
Madam,
yep.
Untuk yang natural ni dia ada mekanisme sama macam tadi ke?
Sama. Maksudnya you replace this one. Ni. Ganti dengan Cn. Okay. Attack daripada belakang. Opposite side lah. Opposite side. Kalau you buat you punya BR dekat sini, that means dia kena attack from opposite side of Br. Okay, so other than OH, Cn minus can also be used as our nucleophile. Right? Cuma dekat sini, tengok reagent dia guna So the reagent used is ethanol. Just now dia guna sodium hydroxide aqueous sebab sodium hydroxide tu behave as the nucleophile as well. But this one the ethanol, reflux tu tetap ada, cuma KCN and then ethanol. Okay, kalau ditanya reagent lah. Okay, kalau ditanya reagent. Okay, again, dia prefers primary ataupun methyl halide. Okay, right. Question 1 and question 2. Draw the structural formula of the product form when 1 bromopropane is boiled with ethanolic potassium cyanide lah. Ni dia just tanya apa? Draw the structural formula. So dia tak mention any mechanism ke apa. So draw the final product lah. Okay, it's boiled with ethanolic potassium cyanide. Ethanolic potassium cyanide. So this is KCN, right? So Cn is the nucleophile used in this reaction. So, okay, let's start from 1 bromopropane. Draw the structure first. Bromopropane, propane. Maksudnya we have 3 carbon. 1, 2, 3. Okay, we have bromine. Carbon number 1. Okay, carbon number 1. And then this one lah, ni 1 bromopropane. So react with KCN, ethanolic. Apa nama ni? Ethanol tadi kan? Ethanolic lah. Ethanol and then we have reflux lah. So boil ni maksudnya dia boleh juga represent reflux. Sebab reflux tu, macam saya cakap, you may Google it. Okay, reflux tu kita involve heating juga. Kita involve boiling. Okay, alright. So, basically ganti je lah this one. 1, 2, 3 kan? 1, 2, 3 betul. Initially 1, 2, 3. So, bila kita ada, gantilah Cn. Siap. Sebab dia tak tanya mekanism. Okay, kalau dia tanya mekanism, macam mana? Okay, kalau tanya mekanism, kita nak kena bagi nampak kan? Everything kan? So, I would suggest you to draw exactly like what we have in the slide just now. So, kita kena buat 3D. Okay, so fokus kita on this carbon sebenarnya. Sebab this carbon is attached to bromine, right? Okay, so carbon. So, bromine. Okay, ini sebab skeletal form kan. So, sebenarnya this carbon has also hydrogen attached to it. Betul tak? Ni rupa dia sebenar sebab ni skeletal kita tak tunjuklah hydrogen. So, kita buatlah hydrogen. Okay, and then another hydrogen edges. Okay. CH2, CH3. Cn minus attack from the opposite side. Kan? Sama kan ni bromopropane. And then jadilah dia akan attach itself. So dia akan tegak dulu. Okay. Apa tadi? CH2, CH3. This one is hydrogen. So this one Cn. This one, ni apa ni? Hydrogen is Br. Okay, this is the transition state. Okay, transition state. And then later, okay, ni dia punya arrow ada 2 je. 1 and 2 dia keluar. Both electron will be given to bromine and becoming bromide. So, dia akan flip to the other side. Okay, so this will be Cn. Okay, so hydrogen here. And then we have another hydrogen. And then give me dashes CH2, CH3. Siap. Okay? Alright. So ni, even though soalan tak tanya sajalah, saya nak tunjuk. Okay. Question number 2. Practice lah, even though dia tak tanya, tapi you boleh practice. Okay. Question number 2. Write mechanism for the nucleophilic substitution when the following alkyl halide react with nucleophile. Okay. Alright. Okay, so as you can see, the nucleophile use is OH minus. So dia straightforward je terus dia guna OH je, dia tak tunjuk sodium hydroxide and whatnot. Solvent or reflux ke, reagent condition ke, dia just tunjuk OH minus. Maksudnya apa nama tu, this OH minus will attack the this is primary alkyl halide. Macam mana tahu primary alkyl halide? Because this carbon is attached to this carbon only. And then lagi dua tu adalah hydrogen. Betul tak? So it is a primary alkyl halide. So di SN2 lah. Okay, so OH akan attack. So for this one, you may refer to the contoh that we had earlier. Okay, cuma contoh tu methyl bromide. But this one is primary alkyl halide. So bila you nak kena buat mechanism, you kena draw macam ni. I would highly suggest you lagi sekali buat 3D, okay? Alright, so Cl, opposite maksudnya yang straight ni, and then you ada begini, apa, wedge, dashes. Okay, so hydrogen, this one, yang ni. Okay, alright, so CH3, right? Dua kali kan, ada dua kan. CH, this one. Sebab kita punya target is this carbon. Ni, this carbon is this one. Okay, alright. So this one duduk dekat kawasan ini. Dan hydrogen and hydrogen. So OH, tak boleh, jangan buat begitu. Melingkang-lingkup pula dia. Okay, so OH will attack from the opposite side. This one. Okay. Right, then proceed lah. Yep.
Yang arrow tu tak payah buat arrow satu. Kan ada dua side dengan satu side. Arrow tak payah buat satu side.
Satu side yang mana
Kan kalau elektron pindah macam anak panah tu ada yang dua arrow dengan satu arrow. Tajam dia tu.
Yang mana Kejap, cuba tengok ni. Dekat mana?
Saya rasa ni lah madam, half-headed dengan
Half-headed arrow. Tak, kita memang pakai full-headed arrow. Kita, like I said, half-headed arrow. Adakah itu you are referring to that? Siapa yang tanya soalan tadi? Okay. Half-headed arrow, kita hanya pakai masa homolytic fission, which only happen to alkane. So, kita dah way past alkane. Dah settle dah alkane. Okay, so kita tak akan pakai half-headed arrow anymore. Okay, we are not going to use half-headed arrow anymore. Okay, so the following will be full-headed arrow. Okay, macam ni kan. Dia full-headed ni sebab ini kan dia share dua elektron. Tapi nanti dia putus ni. Dia putus, so both of the electron will be given to bromine. So this is heterolytic fission. So dia akan jadi bromide nanti. So bromide ion. So dia ada 8 lah elektron kat situ. So jadi bromide ion. So tidak ada lagi half-headed arrow lah. Half-headed maksudnya dia kan bond kan. So dia satu bond ada dua elektron. So satu elektron akan dipulangkan kepada each owner. Itu fungsinya kenapa dia half. Ini satu kepala ni menunjukkan satu elektron. Pergerakan satu elektron. Okay, kalau kita ada dua, maksudnya ada lagi satu elektron. So in total we have 2 elektron. So kalau you pakai dua headed, maksudnya ada full headed arrow. So you are representing the movement of 2 electrons. Okay. So ni lepas ni alkyl halide, halogen, alcohol, aldehyde, apalah semua tu, semua alkene, in fact from alkene, kita memang dah pakai full headed arrow. Okay? Alright.
Okay.
Okay, so for alkyl halide punya reaction mechanism, kita hanya ada dua arrow utama. Two main arrows. One is the nucleophile attack. Secondly, the leaving group of the leaving group of apa nama tu, halogen. They leave the group. Dua saja. Okay? Right. Okay, jom. So any more question related to Sn2 before we proceed to Sn1? Ada? Okay, tak ada. Okay, tak ada.
No, madam.
Alright. Okay, thank you. Okay, now let's proceed to Sn1. Settle Sn2 prefer primary or methyl halide. But Sn1 on the other hand prefers tertiary. Okay, so bawah tertiary ada secondary lah. So with tertiary alkyl halide Sn1 mechanism is dominant. Maksudnya tertiary prefers to undergo Sn1 reaction. The mechanism occurs in two distinct steps. So dia ada dua step. Yang tadi tu ada satu step saja. Sangat terus. Jadi dia ada dua step. So dia form satu step and then proceed to the next step and then finally form product. Okay, so the first step is the departure of the leaving group. Depart. Maksudnya leaving group tu dia akan keluarkan diri dia sendiri. Dia the departure of the leaving group to form carbocation. No wonder lah dia prefer tertiary. Because, okay, this reaction will form carbocation as an intermediate. So kalau form carbocation, tertiary would be more stable lah. Okay, alright. So first step, the leaving group. The departure of the leaving group. Maksudnya bromine, halogen tu akan leave the group secara naturally. Okay. So this is slow step lah. This step is slower because you want the halogen to leave the group naturally. Tapi you create that condition, a condition in which push the the halogen to leave the group. Okay, contohnya kita nak suruh orang ni berhenti kerja, kita tak boleh berhentikan dia kerja suka-suka hati sebab dia melanggar melanggar akta ke apa kan. Tapi kita boleh create surrounding ataupun environment supaya dia stress. Okay, supaya dia stress dan dia sendiri akan leave the company. So that is example lah, contoh yang saya boleh bagi. Okay, so this is what it meant by departure of the leaving group in order to form carbocation. And then bila dah jadi carbocation, the nucleophile attack. Okay, so the nucleophile will attack the carbocation. So this will be fast reaction. Okay, sebab dia daripada unstable to become stable, it is very fast. From stable to become unstable, that one will be very slow. Okay, sebab you daripada stable to become unstable, so you tak prefer lah that keadaan kan, tapi terpaksa. Dia terpaksa, dia makan masa sikit. And then it will happen. Okay, alright. So therefore, the rate can be equal to K times the concentration of the reactant times OH. But OH is zero order. OH concentration is zero order. Okay, because it does not rely ataupun depends on the concentration of OH. Okay, dia tidak bergantung pada concentration of OH. That's why dia zero order. Okay, dia bergantung kepada carbocation tu. So the formation of carbocation. So bila carbocation is formed, so dia akan, the attack of the nucleophile will be very fast. Okay, alright. So in general, whatever it is, kalau you are asked to write you are asked to predict the product form. Okay, it is still substitution reaction. Cl will be replaced with OH. Itu sahaja. Okay, Cl will be replaced with OH. But please bear in mind the condition now is a little bit different. Okay, so it is still reflux condition, but the apa nama tu? The reagent used is not necessarily need to be sodium hydroxide, so we can use H2O. Okay, we can use H2O. H2O will supply the OH minus lah. Like I said just now, OH will not be the determining step. Okay, macam SN2 tadi, OH tu penting. Sebab dia yang attack. Yang ni dia tak attack. Kita create environment. Okay, nak memaksa dia keluar. Okay, jom tengok dia punya mechanism. So step 1, the Br, the halogen will be leaving the group. Okay, so kita tunjuk keluar. So it will take both of the electron. Okay, so it will take both of the electron. So it will leave the group and becoming bromide ion. And leaving behind the carbocation. So this is the carbocation. So this is very slow reaction. And then secondly, this carbocation will undergo nucleophilic attack from H2O. Okay, so OH akan masukkan attach itself to the carbon. So dia akan jadi OH. Okay, this one will be broken down. Sebenarnya ada step lagi ni. Ini dia cut short ni. Okay, dia cut short. So ini akan dia attack. So macam biasa dia attach itself. So sebenarnya another H2O akan attack this hydrogen keluarkan macam hydration last time. Ingat hydration? Sama lah. Okay, dia punya sebenarnya macam mana H ni boleh di-remove out from this H2O. Tapi kita cut short, you just tunjuk the attack of H2O, okay, to carbocation. Dah siap, masuklah OH ke situ. Okay, tapi ada 2 step, the formation of carbocation and then finally the attack of nucleophile. Attack of nucleophile. Okay, alright. Okay, so senang bila dah tahu dia punya preference. Okay, tertiary, okay, will prefers to undergo SN1. Ingat, tertiary will prefers to undergo SN1 because SN1, because tertiary will form more stable carbocation compared to methyl halide dengan primary. Okay, and then kalau tak ada tertiary, then secondary pun prefers, okay, prefer juga to undergo SN1. Last time, secondary ni dia in the middle. Sometimes it can perform SN1, sometimes it can also perform SN2. It depends on how crowded the molecule is. Okay, kalau dia secondary tapi dia punya group yang attached to the carbon tu not very bulky, CH3, then dia prefers, it may undergo SN2. Kalau dia punya group dia bulky, macam CH2, CH3, and then this is isopropyl, and this is methyl. So very bulky kan? Okay, secondary carbocation. Okay. I see. Okay. Kenapa macam ni? Pelik tak tengok ni? Kenapa ni sama? Betul kan? Tengok ni. Ini tertiary betul. Betul tak? Betul tak? This is tertiary, correct. But this is also tertiary. This is not secondary. Nampak tak guys? Ini betul. Ini secondary sebab this carbon attached to this two carbon. But this one bukan secondary carbocation. Ini tak betul ni. Kena ganti dengan H. Ganti. Okay, please edit your slide. Betul kan?
Yang bawah pun bromomethane kan? Gitu.
faster than bromoethane. Ya. Kejap. Yang this one faster than bromoethane. This is correct. This is ethane kan? Okay, jap. Dia nak cakap secondary carbocation ni, this is with reference to SN1. Okay, maksudnya secondary carbocation prefers SN1. So maksudnya dia lebih laju daripada, this is bromoethane. Betul tak? Ni, this one is bromoethane. Ni ethane, ni bromo kan? So this is bromoethane. So secondary carbocation perform SN1 faster than primary. Betul lah statement dia ni. Okay, cuma yang tadi tu dia salah. Sebab dia refer kepada bromomethane. Okay, faham tak? Ke pening? Sebab tadi kita buat SN2. SN2 kan dia prefer methyl halide dengan primary. But this one, SN1, dia prefer tertiary. Dan secondly, dia prefer secondary. Okay. So of course lah dia lebih secondary, lebih laju daripada bromoethane. So this is bromoethane. Bromoethane is primary. Okay. Alright. Okay, so if we were to compare SN1 and SN2, katakanlah question asks for the comparison of SN1 and SN2. So how would you compare these two? Okay, SN2 one step mechanism. So don't get confused with the number here, even though it is SN2, but it is a one step mechanism. SN1 on the other hand is a two step mechanism. Jangan ingat two step, bukan. Two ni dia bimolecular, maksudnya the reacting molecule. Okay, dia ada dua reacting molecule guys tu. So it is bimolecular. This one is unimolecular. This one yang represent this number. Reactivity order, SN2 prefer methyl and then primary. Dia sangat-sangat tak prefer secondary dengan tertiary. Sangat tak prefer. But on the other hand, SN1 is opposite to SN2. It prefers tertiary over primary and methyl. Okay, so no reaction will take place for tertiary alkyl halide, but for SN1, no reaction will take place for methyl halide or primary alkyl halide. So, try buat checkpoint 20. Arrange the following bromoalkanes in increasing order of reactivity towards SN1 mechanism. Dia kata towards SN1 mechanism. So we know that SN1 prefers tertiary, right? Baru belajar tadi kan? Jangan pening pula. Dia prefers tertiary. Maksudnya tertiary akan ada formation of carbocation. And then we have two steps. First is the formation of carbocation. And then secondly, we have the nucleophile attach itself to the carbon. Okay, so kerja kita adalah mencari tertiary. Increasing order kan from the weakest, okay, yang paling tak prefer to undergo SN1 to the one that prefers to undergo SN1. Okay, alright, so yang mana? This is, kita identify dulu, okay? Alright, so this one attached to Br. So this carbon is tertiary. How about number 4? This carbon attached to Br, right? So this one attached to this carbon and also attached to this carbon. So this is secondary. Jangan rasa terpengaruh dengan dia punya structure yang bulky kat belakang tu. Kita nak identify the degree of the carbon, the classification of the alkyl halide. So kita refer to the carbon that is directly attached to the halogen. So this carbon is only attached to this carbon and also this one. The rest tu dia sebagai dayang-dayang saja. Okay, so this secondary. How about this one? This is methyl halide. This is not primary, because this carbon is not attached to any other carbon. How about this one? Number 1. Okay, this carbon dia attached kepada Br kan? And it is also attached to only to this carbon. Betul tak? Dia hanya attached pada this carbon saja. The rest are all H dengan H. So this one is primary. Jangan takut tengok yang belakang-belakang ni serabut. Kalau tak biasa, you kembangkan. You expand. Baru you nampak the degree of this, the carbon. Okay, so now baru you boleh arrange. Okay, increasing order. So you start with number 2 yang paling lemah. Okay, and then primary, we have primary there. 1. And then we have number 4. And we have number 3. Increasing reactivity. Or you may also use this one. Okay, kalau rasa pening nak pakai ni, jangan pakai ni. Pakai arrow and then tulis kat bawah. Nanti bila dalam exam panik, tak tahu ini lebih besar ke, ini lebih kecil ke, mana satu. Okay, alright. Compound 3, this one, reacts with Cn minus. Okay, so this is the nucleophile. Write the nucleophilic substitution mechanism. Okay, alright. So it is SN1. Apa yang you kena buat adalah you basically use this mechanism step. It's just that you replace with Cn. Okay, alright. So is it still bromine just now? Yes, still bromine. So we remain this one. Step there exactly the same. It's just that this one you replace with Cn. Tada, siap. This one ganti dengan Cn. Siap. Okay, that will be the step for the mechanism lah. Sebab dia tanya apa? Mechanism. Make sure that you have all the arrows, okay? Yep, like this one. Okay. Okay, state whether each of the following reaction is likely to be SN1 or SN2. Guys, faster. A, is it SN1 or SN2? Come on.
SN2.
Okay, SN2. How about others? Do we have SN1?
SN1.
SN1. SN1. Lagi?
SN2.
SN2. Okay, SN1 ada, SN2 ada. Wow. Okay, campur-campur. Okay, teka. Bukan teka lah. Based on what you have learned just now. Okay, so let's write out this checkpoint. Kita as if macam you masuk exam terus. Dengan apa yang you ada information just now. So, cuba. So, semua kena cuba. Tengok aja kan, boleh tahu kan. Cuba.
SN2.
SN2, okay. Lagi. Keep coming.
SN2.
SN2. Banyak SN2. Oh,
SN2.
SN2. Okay. So ini ada SN2 and SN1. Okay, alright. B pula. Cuba try B. B. Come on. SN1 ke SN2?
SN2.
SN2, okay lagi. Ada SN1 ke?
SN2.
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 Okay, ada SN1. Okay, ada yang cakap SN2 and okay, how about lagi do we have SN1? Supporter untuk SN1? SN2 lagi?
SN2.
Okay, alright. Okay, since tadi ada yang teka SN1 juga, saya tulis je dulu. Okay, how about C guys? C.
SN1, madam.
SN1.
Ya, ada tak yang cakap SN2? Okay. Tak ada rasanya.
SN2.
Ada juga. Okay, alright. So let's go through the question. State whether each of the following reaction is likely to be SN1 or SN2. Okay, alright. So These are all alkyl halide. Okay, so we have to determine the type of reaction that this molecule prefers to undergo. Okay, so the tips is to identify the classification of the alkyl halide. Okay, sebab kita nak tahu SN1 prefers tertiary. SN2 prefers methyl and primary. Kita kena decide on this first. Okay, you kena clear about this first. Okay, so when you have the molecule, so you kena identify. How do we identify? Okay, kadang-kadang student dia get confused with the molecule itself. Dia macam rasa macam terganggu. Okay, focus. Okay, so target on the halogen, and then this halogen must be attached to the carbon. So carbon yang kita target, sebab kita nak identify whether the tertiary ataupun primary kan. So the type of alkyl halide depends on the degree of the carbon that it is directly attached to. Okay, so this carbon lah. Jangan tengok dah carbon lain tu. Carbon lain tu dia dayang-dayang aja, menyibuk. Okay, ini pun jangan, ini just macam, I mean dia tidak terlibat directly. Okay, so you kena identify this carbon, the degree of this carbon. Okay, so the degree of this carbon is, okay, dia attached to this carbon, 1, and then another carbon, 2, and then this carbon, the third one. So dia adalah tertiary.
SN.
Okay, dia adalah tertiary. Dia adalah tertiary carbon. So if it is a tertiary carbon, that means dia akan undergo SN1, not SN2. Okay, tu je dia punya, I mean basically BR ni nanti akan replace dengan CN kan. Settle dah. Tapi kita nak kena determine whether dia SN1 or SN2. Focus on that carbon yang directly attached to the halogen. Okay, let's look at B. Okay, so this is the halogen, right? So the target carbon will be this one. Jangan tengok dah carbon lain. Okay, right, so focus on this carbon. Okay, so kita kena make sure that this carbon should have 4 bonds attached to it. Okay, so since this is skeletal, so we have 1 hydrogen there and the other hydrogen there. Okay, yang kita tak nampak. Kita just want to be confirmed that this carbon is it primary, secondary or tertiary? Okay, so since it has 2 hydrogen attached to it, so it is also attached to this carbon, right? Directly attached to this carbon. So dia hanya attach kepada satu carbon saja. Yang lain-lain ni tak attach kepada dia pun. Dia jauh-jauh. Kita nak yang directly attached to the carbon. So dia hanya attach kepada satu saja. So this carbon is primary carbon. So kalau dia primary, dia akan undergo SN2, not SN1. Okay, so SN2. So dah tahu dia jadi senang. Dia tinggal nak teka je. Teka. Right, C. Okay, focus on the carbon yang attached to the halogen. So this carbon. Okay, so this carbon is attached to this first carbon, second carbon, and third carbon yang directly attached to it. So it is tertiary carbon. So kalau dia tertiary carbon, so this alkyl halide is also a tertiary alkyl halide. So kalau tertiary, it will be SN1. Okay, tapi dia the way dia react, so basically dia just substitute je. BR ganti dengan CN, see? BR ganti with OH. See? Tempat yang ada halogen tu, I replace with OH. Okay? Okay, settle. Okay? Alright. So, janganlah salah. Sebab dia, once you dah tahu, dia prefer apa, it will be easier. Senang. Kalau keluar objektif, lagilah senang. Okay? Cuma you kena identify the degree of the alkyl halide first. The classification of the alkyl halide. Okay, so done with the substitution reaction. Okay, so next we have the application of alkyl halide. So alkyl halide can be used for other application. So it can be used to prepare other reagents sebenarnya. Okay, so before we go further, do you have any question related to nucleophilic substitution just now? Tak ada. Okay, tak ada.
No, madam.
Alhamdulillah. Okay, tak ada. So let's proceed with preparation of Grignard reagent. Grignard reagent. Okay, so a reaction of alkyl halide with metal, for example, magnesium produces an organometallic, organic and metal. So it becomes organometallic compound that is called Grignard reagent. Okay, Melayunya Grignard. Kalau rasanya saya pernah dengar dia pronounce as Grignard. Okay, Grignard reagent or Grignard reagent. Okay, doesn't matter. So Grignard reagent is a magnesium salt and sensitive towards moisture. Thus, it must be handled in the absence of water. In this reaction, dry ether or dry THF is often used. Okay, so in order to prepare this reagent, it must be in the absence of water. Maksudnya water should not be in the reaction. So we have to make sure that the condition is dry. Okay, so one of the way is to use solvent that avoid water from interfering with the reaction, with the preparation. Okay, right. So basically we can use we use alkyl halide lah. So we use alkyl halide as our starting material. We react it with magnesium in dry ether or dry THF. So these are the condition and dia punya reagent lah. Okay, dia kena ada dalam dry ether. So you akan produce this. These are what we call Grignard reagent. Okay, Grignard reagent. Senang saja, simple saja. You initially macam ni kan, these are all alkyl halide. So bila magnesium react dengan this alkyl halide, so magnesium duduk dekat tengah pula. Okay, magnesium duduk dekat in the middle between the carbon and halogen. Dah siap. Inilah namanya reagent kita. Ada gunanya lah reagent ni, nanti kita akan guna dalam other reaction. But this is just for preparation of Grignard reagent. In case you are asked in the exam how to prepare the Grignard reagent. Okay, so basically you just kacau, bukan kacau, yang lain tu dia bagi macam mana serabut pun the molecule tu remain as is. You don't have to modify anything except for this one. Dekat X tu, you go for the X, you target for the halogen, and then X2, you place the magnesium, and then only you place the X. Itu saja. Dia punya yang belakang-belakang yang lain-lain ni, you remain macam biasa. You don't alter anything. Tulis balik, lukis balik macam biasa, just letak Mg and then baru X. Initially X kan, and then ganti dengan Mg lepas tu X. Dah siap. This is your reagent. These are your reagents. Okay, don't forget the condition. So the carbon magnesium bond is polarized, making the carbon atom as nucleophile and basic. Okay, so CH3, CH2, Br. Okay, so normally bila dekat sini, ni akan positif, this one akan negatif, right? So this carbon ni will be electrophile sebab dia bind dengan bromine, directly to bromine. When it combine with magnesium, we know that magnesium is metal and metal is electropositive, right? Okay, so when it combines with metal, carbon boleh belagak sikit lah. Okay, carbon in this case will become slightly nucleophile. Slightly nucleophilic, okay, because magnesium will always have positive charge. Okay, so dia akan positively charged and the carbon now become carbanion. Carbon anion. Ataupun nucleophile lah. Okay, they behave as nucleophile and this is basic. Okay, strong Lewis base act as nucleophile. Okay, so ini kita boleh gunakan sebagai reagent in other reaction. So we will be using this one in aldehyde and ketone reaction. Okay, so ni later lah. Ni just nak tunjuk preparation of Grignard reagent because we are still in the topic of on the topic of alkyl halide. Alkyl halide can be used to prepare this reagent. Okay, so like I said just now, so it provides a higher carbon chain the product has one more carbon atom than the Grignard reagent. Okay, for example, okay, so bila you react kan, contoh we will go into detail for this reaction in aldehyde and ketone later on. So you react the reagent that you produced just now, the reagent yang you produced just now, with CO2. Okay, so this is CO2. Okay, when you react this Grignard reagent with CO2 in this condition, but this time around you will need water lah, water and also acid, so it will form H3O+. So these are the two conditions. So it will combine. Okay, the MGBR will be kicked out. Dia akan keluarkan diri dia, so dia akan combine. Okay, so C ni akan join. So dia ada pertambahan carbon chain. Nampak tak? Initially dia ada 2 carbon sahaja. So once they combine with CO2, so dia ada 3 carbon. 1, 2, 3. Okay, so Grignard reagent ni boleh menambahkan carbon chain. So dekat sini, not only dia, that's why we need this H3O+. Initially dia CO2 kan. So the O will remain sebagai O, satu saja. The other one will be reduced to OH. Okay, dia akan reduce to OH. So this is the byproduct lah, MgBrOH. So it can also be used to react with formaldehyde. Okay, so initially dia ada 2 carbon je, nampak tak? 1, 2 carbon. So when it reacts with this aldehyde, so this is what we call aldehyde. Okay, dia react, so nampak tak pertambahan carbon chain dia? Dia jadi 3 carbon. Okay, so dia dah jadi 3 carbon dekat sini. So H will be reduced, H akan jadi OH. So this is alcohol. Okay, so this is to highlight that when you use Grignard reagent, it helps to lengthen. Okay, it helps to lengthen the carbon chain. Okay, initially it has less carbon, so once the Grignard reagent is added, so it becomes the molecule will have more carbon. Okay, the product will have more carbon in it.
Madam.
Yep.
Kalau untuk reaction Grignard reagent ni, dia maksudnya dia punya main product is propanoic acid lah kan. So byproduct dia organometallic compound tu.
Come again?
Untuk yang Grignard reagent ni, main product dia
preparation ke ataupun reaction with Grignard reagent?
Reaction tu lah. So maksudnya dia punya main product tu supposed to be propanoic acid lah. So organometallic compound tu dia punya byproduct dia.
Yes. Okay, so not only propanoic acid, it can also form propanol, alcohol. So ni macam sebab nak go into detail pun nak kena tengok mechanism macam mana it reacts first kan. So that's why saya kata in detail we will cover this in aldehyde and ketone. Supposedly lah, takut dia dah keluarkan pula kan. Tapi dia apa nama tu, sebab saya tak ingat dah dia punya reaction. So not only dia carboxylic acid, it can also produce alcohol. And other than that, produce aldehyde ke? I don't think so. Carboxylic acid and alcohol, I think. These two. Okay, so ni kebetul dia combine dengan CO2. Kalau dia combine dengan I mean, can also combine dengan ketone. Ini aldehyde can also combine with ketone. So bila dia combine with ketone, it will form secondary alcohol. Kalau dia combine with aldehyde, okay, aldehyde, it will form primary alcohol. Okay, tapi kalau dia combine with CO2, dia akan, yang carboxylic acid ni I'm not sure. Okay, dia punya condition dia. Okay, so tapi nanti kita akan tengok lah in aldehyde and ketone. So basically, dia akan form 2 produk. So ini akan remove, keluar. Okay, and then you wonder tak kenapa dia ada OH kat situ? Because of the presence of H3O+. So dia sebenarnya organic chemistry ni, you have to look at dia punya mechanism. Okay, and from the mechanism you will be able to understand why at the end of the day you produce these 2 products. So kalau tak ada, kalau dia tak bagi mechanism tu maksudnya lebih kepada kena hafal lah. Okay, tapi kalau whoever interested to know more, rasa macam organic chemistry ni macam ada chemistry dengan aku. Okay, so you can always look for this mechanism online ataupun daripada textbook. Okay, tapi memang kalau daripada mechanism lebih mudah kita faham. Okay, lebih mudah kita ingat sebenarnya rather than kita tengok atau kita kena hafal macam tu kan. So kita kena tahu the chronology. Bila kita tahu proses, automatically dia akan stick longer lah. Okay, alright. So like I said, this is just to highlight that when using Grignard reagent, it adds carbon to the chain. Okay. Apa ni? Oh, application on the usage of Grignard reagent. The Grignard reagent, apa dah ni? Aduh. The Grignard reagent is a key step in the industrial production of tamoxifen. Okay, a non-steroidal anti-estrogen drug, which is currently being used as treatment for breast cancer patients. Okay, all right. So, this application of Grignard reagent, bukannya kita just belajar untuk buat reaction. Okay, nak introduce to you guys the alkyl halide and whatnot. So of course it has its own application, especially in the medical line. Okay, so it has been used to prepare drug. Okay, to treat the breast cancer patient. So as you can see, ni kan. This is what we call ketone. Like I said just now, ni ketone ni. Sebab dia duduk dekat tengah-tengah. Okay, so we have carbonyl group. So we have carbon. So this is what we call ketone. And then this is the reagent, the Grignard reagent just now yang kita prepare. Grignard reagent Mg, Br. So these are the alkyl group. Br kan? Br alkyl halide kan? So they add in the Mg. So this one will be used, okay, to react with this drug, okay, to produce this tamoxifen. So nak tambahkan the OH je dekat situ. So dia akan attach the aromatic compound here, the aromatic part here, and then you ada OH dekat situ. Okay, so basically this bond will be broken down, so dia akan form another bond, another two bonds. So one is for OH, the other one is for the aromatic ring to be attached to the carbon here. Inilah tamoxifen. Inilah drug yang digunakan to treat cancer. Okay, itulah kegunaan Grignard reagent. Banyak sebenarnya organic chemistry ni. Okay. Draw the structural formula of the product form A, B, and C. Alamak. Okay, so you identify. Okay, this is alkyl halide, and then you have Mg. Oh, you can identify. Okay, apa nama reaction ni? This is what we call preparation of Grignard reagent. Okay, sebab Mg belum masuk lagi ni. Okay, kita nak prepare, nak insert the Mg. So what you need to do is to draw everything the same. Cumanya you letak Mg dulu, and then baru you letak Br. Okay, letak Mg dulu, baru you letak Br. Siap dah? This one pun sama. Letak Mg dulu, and then you letak I. Siap dah? Simple as that. Okay, sebab dia tak tunjuk mekanisme kan? Siap. Okay. So, saya kata organic chemistry ni sebenarnya senang. Cuma kalau dia tanya reagent, kan? Leceh lah kita nak kena hafal. Tapi kalau dia setakat tanya produk, sekejap aja. Okay? Siap lah. Okay, alcohol guys. Okay, any question for alkyl halide just now before we proceed with alcohol? After alcohol, we have two more subtopics. We have aldehyde and ketone, and then carboxylic acid and its derivative, and then we are done. Okay, so obviously I need 2 hours extra to cover for these two remaining subtopics. Okay, so kena carilah kat mana nanti nak kena suggest. Okay, nak dapat suggestion daripada class rep. Ayu. Okay, so may I proceed, guys?
Yes, madam.
Yes.
Okay, alright, tak larat dah ni sebenarnya. Okay, dah terlarat dah ni. Tapi tak apalah. Sikit je lagi. Saya fikir akhir minggu ni nak pergi beraya. Nak pergi relax-relax. Nak pergi santai-santai. Tak apa. Saya kerja keras minggu ni. Okay. Alright. Okay, next. Bismillahirrahmanirrahim. May Allah ease. Okay. Right. Next will be alcohols. Okay. So these are the learning objective for the LOs for alcohols. Okay, make sure that you cover all of these learning objective for alcohols. Okay, all right, because the exam will be based on the learning objective. Okay, all right, moving on. The introductory part of alcohol. So structure of alcohol, it can be aliphatic. Normally it will be aliphatic. Okay, or it can also be known as hydroxy compounds. Which means that it consists of hydroxyl groups. Okay, so the general formula is CnH2n plus 1. It's just that one of the hydrogen is being replaced with OH. Okay, so one hydrogen atom replaced by OH group. So one group bonded to one of sp3. So this carbon is sp3 hybridization. Okay. So example, okay, normally these are the common alcohol that we normally see, okay, ataupun we normally use at home ataupun at school, okay. So ethanol, okay, so ethanol can be produced from grain, can also be obtained from grain alcohol, okay, through fermentation of sugars in grain, okay, so we can obtain alcohol through fermentation. So it normally used as alcoholic beverages. Okay, so it can also be used as gas for transportation. Okay, this is alternative to fossil fuel. Okay, fossil fuel. So ethanol can be used as fuel. Okay, so this is still under research. Next we have isopropyl alcohol. Okay, it is also known as 2-propanol. It can be used as rubbing alcohol. Okay, untuk sanitization. And it is also poisonous, okay, guys. And methanol, okay, so it can be obtained from wood, okay, from thermolysis of wood. So it can be used as paint solvent, and it is also poisonous. Okay, methanol is very poisonous, okay, guys. So avoid from inhaling the methanol. Ethanol, walaupun dia hanya pertambahan satu karbon saja, tapi dia punya perbezaan tu sangat ketara. Ethanol is very poisonous. Ethanol not as much. In fact, kita boleh consume. Kita ada limit lah, okay, to consume ethanol. So, bukan to consume ethanol. So, ethanol is one of the content in the alcoholic beverages. In fact, dia adalah main content, okay, in the alcoholic beverages. Tapi of course lah, ada percentage. Okay, classification of alcohol. I'm not going to go into detail on this. It's basically the same as alkyl halide last time. Okay, it's basically the same as alkyl halide last time. So it depends on the carbon. Okay, it depends on the carbon that the OH is directly attached to. Like for example, okay, so this is primary alcohol. Why is it primary alcohol? Because this OH attached to this carbon. So this carbon is primary carbon because it is only attached to this one carbon. So therefore, this alcohol is considered as primary alcohol. Okay. So we have secondary, tertiary, and methyl alcohol. Okay. Kalau you faham your alkyl halide, classification of alkyl halide, so you should not have problem in understanding this classification of alcohols. Okay. All right. Nomenclature of alcohol. Okay. So first, like always, you have to find the longest chain containing OH group. Okay, dia mesti OH group tu mesti include in the parent chain lah. Okay, so you nak, because later dia punya parent name tu we have to replace with OL. It should end with OL. Okay, alcohol kan like methanol, propanol, hexanol. Okay, so you should the parent chain should consist of the hydroxyl group. For example, this one kan. Okay, you can identify the continuous and parent chain, tapi it must consist of the hydroxyl group. Itu syarat wajib lah. Okay, so dekat sini 1, 2, 3, 4, 5, 6. So you ada 6 alcohol, 6 apa ni? Apa beza this one dengan this one lah? Oh, okay. Ini okay lagi lah. So 6. This one also 6. Tapi bila you nak numbering, kenapa? Numbering dia. Okay. Step number 2, number the alkene chain beginning at the end nearer the OH group. So, for this one, the focus is more on the functional group. So try to get the lowest number as possible for the functional group. Like contoh what we have here. Okay, so we have dua options. Satu, if we start from right, and also if we start from left. If we start from right, kita akan dapat OH pada carbon number 1. But if we start from left, kita akan dapat OH pada carbon number 6. So which one kita prefer? Kita akan go for the lowest number possible. Sebab kita dah ada priority sekarang. Okay, kita dah ada priority. Tak macam alkyl halide last time. Kita tak prioritize the alkyl halide. Kita tak prioritize the halogen. Okay, but alcohol kita dah kena prioritize. Numbering dia kena the lowest. Okay, so macam biasa identify number the substituents. Okay, what else? Basically the same lah. Okay, sama saja. You kena go for the low, apa nama tu? If there are two substituents on the same carbon, give both the same number. There must be as many number in the name as there are substituents. List substituents in alphabetical order. Okay, alright. So let's say, for example, kalau you start from below going up, from bottom going up to the left, you akan dapat 6 carbon. Kalau you go straight here, pun you dapat 6 carbon. Sudah. Habis kita nak prioritize apa? Next, kita kena prioritize the number of substituents. If we go for this one, going from bottom to the top, kita akan ada berapa substituent? 1, 2, 3. Right? Kita ada 3 substituent. But kalau kita pergi straight, kita ada 1 je substituents. Okay, so mana yang nak prioritize? So we will prioritize the one that have more substituents, not this one. Okay, so this one kita ada 3 substituents, 1, 2, 3, but this one we only have 1. Okay, biasalah. Lepas tu write the name as single word. Okay, so you should make sure that the ending should be all. Okay, if it is an alcohol, so the ending should be all. Okay, write the IUPAC name for the following compound. Okay, nak try mana ni? A, B, and C. Ke tak nak? Nak terus proceed? Which one do you prefer? A, B, or C?
Boleh, madam.
Nak apa?
Proceed, madam.
Proceed, madam.
Proceed okay. Okay, jom. Okay, you buat sendirilah Okay, alright. So let's proceed. Okay, general preparation of alcohol. Okay, hydration of alkene. General preparation of alcohol. So basically we can prepare alcohol through satu, hydration of alkene. So we have learned this right last time kan, from in alkenes, alkenes can undergo hydration to form alcohol. So cara nak prepare alcohol adalah through hydration of alkene. So remember apa dia punya condition? It should be H3O+. Ataupun remember H2O ada phosphoric acid. Ingat? Okay, and alternatively, secondly, okay, we can also prepare alcohol through nucleophilic substitution reaction of alkyl halide. Okay, so we can prepare alcohol from the nucleophilic substitution of alkyl halide, which we have learned just now. Kan kita baru belajar tadi, kita nak ganti this Br with OH for example, so you will produce alcohol. Okay, alright. And we can also, ini ada extra lah, okay, we can also produce alcohol from the reduction of aldehyde and ketone. Kita boleh reduce aldehyde and ketone to produce alcohol. See, this is aldehyde. How do we know that this is aldehyde? Because dia ada carbonyl and then dia ada hydrogen. So this is aldehyde. Ketone on the other hand, this is not ketone. Ayu. This is not ketone. This is ketone kena duduk tengah-tengah kan. So see, the carbonyl should be located in the middle between the two carbon. Okay, so this one should be R. Here should be R also. So please. Okay, please correct your slide notes. Okay, replace the hydrogen with R. Then only it represents the ketone. Okay, alright. So kita boleh reduce this aldehyde. Ini dia punya reagent ni panjang sikit lah. Reduce maksudnya you supply hydrogen. So this is what we call reducing agent. Kenapa dia reducing agent? Because dia ada hydrogen ada 4 ketul kat situ. Remember CHM096 last time? This is what we call oxidizing agent kan? So dia boleh oxidize others because of it has 4 oxygen atom. It can supply 4 oxygen atom. So same goes to sodium borohydrate. Okay, so this is a very strong reducing agent. That means it can reduce this molecule into alcohol. Okay, and then you should have this H3O plus as well lah. Okay, so dia bila aldehyde, bila dia reduce, it will form primary alcohol. Ini dah sedikit lebih kepada memorization lah guys. Sebab kalau nak ajar mechanism, terlampau overwhelming pula, terlampau banyak. So the only option is for you to memorize. Okay, aldehyde undergoes reduction. Apakah reducing agent yang dipakai? Sodium borotetrahydrate. Sodium borohydrate. So student saya ajar, dia sebut panjang tu dia hafal nabeh 4. Okay, nabeh 4. Senang untuk dia nak hafal. So nabeh 4. So make sure you Na sodium, B boron, H4. So dia nabeh 4. Okay, and then H3O plus. So it will produce primary alcohol. Kalau you reduce ketone, sama reagent dia, tapi this is ketone, you akan produce, nampak tak you supply hydrogen sebenarnya? Okay. Sebab dia dah jadi 4 tangan lah ni, 4 single bond kat situ. Ada 4 single bond. So ada, this one will be broken down. So dia akan form lagi 1 bond dekat situ. So that bond, okay, will be added with hydrogen. Ni daripada nabeh just now. So yang mana yang ada oksigen tu dia akan reduce kan. So you kena tambah hydrogen lah dekat situ. Okay, ingat yang oxidation last time. Yang mana ada hydrogen, kita kena tambah oksigen. Tapi ni reduction kan. So yang mana ada oksigen, kita kena tambah hydrogen. Kita kena tambah hydrogen. But this is reduction. So yang mana ada oksigen, kita tambah hydrogen. Okay. So OH dan H. So this is primary alcohol. Kalau you are using aldehyde. But if you are using ketone, it will produce secondary alcohol. Lagi sekali, ini pun tak betul. Please ganti dengan R. Barulah ni jadi secondary. Okay, so this is secondary alcohol. Okay guys, so ingat kalau pakai aldehyde, you will produce primary alcohol. Kalau you pakai ketone, you will produce secondary alcohol. Okay, alright. So fourthly, we have reduction of carboxylic acid and ester. So kita boleh produce alcohol from the reduction of ester. Okay, from reduction of carboxylic acid and ester. Okay, O lah ni kan, O kan. So carboxylic acid, bila kita reduce kan, again, liah. Ni previous student saya ajar, panggil dia Liah 4, madam. Untuk senang memorization. Lithium aluminium hydride. This is also very good strong reducing agent. So kita ada dua very strong reducing agent, Liah 4 and Nabeh 4. Untuk memorization sick lah, okay. Right, so when you reduce this, so yang mana ada O tu, okay, dia akan break, you akan tambah OH dekat situ. Bukan. Remain the OH, so kick out the oxygen. So dia akan jadi secondary alcohol. Okay, dia akan jadi secondary alcohol dekat situ. Same goes for ester. Okay, it will also form the secondary alcohol. Okay, ini all the best. Okay, mudah-mudahan you boleh memorize lah. Okay, alright. Okay, conversion of alcohol into alkyl halide. Okay, tadi dalam alkyl halide just now, we want to convert alkyl halide into alcohol. Okay, so in alcohol, we want to convert alcohol into alkyl halide pula. Okay, nak convert. So, it is still known as nucleophilic substitution, guys. Okay, one good thing adalah kita akan menggunakan SN1 and SN2. Okay, so we will be applying the concept of SN1 and SN2 for alcohol. So, dah jimat sikit dekat situ lah. Okay, bukan something yang baru, you have been introduced to it before. Okay, so you nak convert this alcohol, reaction of alcohol into alkyl halide. Okay, so this one, for example. So this is tertiary, right? Ni tertiary ni. So kalau tertiary, it will undergo SN1. Okay, tertiary, remember, it will form carbocation, tertiary carbocation. So Br, in this case, for SN1, we need to use HBr. We can use HBr. HBr is not that powerful. Tapi we know that when tertiary alcohol is formed, tertiary carbocation is formed, dia dah very unstable. Dia akan react dengan siapa-siapa yang ada dekat kawasan tu. Walaupun orang tu tak powerful enough. Okay? Sebab dia is already in unstable state. So Br minus act as the nucleophile, replacing the OH group. So tertiary alcohol react with either HCl or HBr at room temperature by an SN1 mechanism through a carbocation intermediate. Okay. So kita tak bagi mechanism dekat sini. For the mechanism, you can refer to alkyl halide slides. Okay. Basically, you just ganti yang Br tu, halogen tu, ganti dengan OH. Itu saja. As simple as that. Okay. Alright. So that is for SN1. You react with hydrogen halide. Nampak reagent dia yang berbeza. If we have primary alcohol, so this is primary alcohol. So we know that if it's primary, it will undergo SN2. Right? Okay. So, SN2 basically sama, dia lalu transition state tu, yang satu step saja tu, yang dia ada 5 bond as dia punya transition state. Okay, alright. But this time around, we have to use inorganic halides. We cannot use HCl, tak boleh. Tak boleh. Okay, you cannot use HCl. Macam SN2 tadi, kita boleh, SN1 just now, we can use HBr. Okay, but SN2, we cannot simply use HCl. Kalau HBr ataupun HCl lah, tak boleh pakai hydrogen halide. We have to use this reagent. It is known as inorganic halide. Because why? Dia able to supply Cl5 dekat situ. Okay, sebab dia nak attack kan. SN2 dia attack. Dia attack from opposite side. Dia kena attach itself to the carbon. Attack from opposite side. So it need to use something that is even powerful than, more powerful than the hydrogen halide just now. Okay, tapi at the end of the day, OH ni ganti je dengan Cl. Cuma reagent use need to be suitable reagent lah. Okay, so primary and secondary alcohol are much resistant to hydrogen halide. That's why we cannot use hydrogen halides. Okay, so we have to convert alcohol that is primary and secondary to a haloalkene, can be done by using PBr3, PCl3, PCl5 or SOCl2 through an Sn2 mechanism. Okay, dia punya reagent dia yang berbeza dekat sini. You kena use any of these four, depending on kalau dia nak chlorine, that means you can use PCl3 dengan PCl5 ataupun SOCl2. But if the Br is used, that means you have to use PBr3. Nampak lah. Okay. Dia punya step tu basically sama. Okay, draw the structural formula of A, B and C for the reaction below. Dia tanya apa? Draw the structural formula of A, B and C. Alah, A, B and C. Okay, so OH. And then tengok reagent dia pakai PBr3 kan? Okay, alright. So sajalah nak alang-alang kita dah buat ni. Kita identify lah what type of reaction. Okay, for of this alcohol. In order to produce the haloalkene. Okay, so this carbon is secondary carbon. Okay, because it is attached to these two carbon. So this secondary, that means it will undergo Sn2. Okay, Sn2, so memang kena pakai PBr3. Tak boleh pakai HBr, no. Okay, alright. So, tapi dia nak tanya, apa nama ni? Dia nak tanya product form kan? Ganti je lah this one with BR. Siap. Okay, alright. This one is, this carbon is tertiary. Okay, so since this is tertiary, so it will undergo SN1. SN1 prefers tertiary carbon ataupun tertiary alcohol. Okay, but in terms of the product, just replace the OH with Cl. Okay, so since this is tertiary, you may use HCl. Okay, you can use HCl because HCl is not that powerful. Because kenapa? Sebab dia dah form carbocation. Carbocation tu is already unstable, so it will react with anything yang ada around there. Okay, walaupun kita ada Cl minus, satu je Cl minus, so dia still boleh react with the carbocation. Alright, next. Okay, this one. Okay, this is primary carbocation. Primary alcohol. Okay, so therefore it will undergo Sn2. Okay, Sn2. So that's why dipakai thionyl chloride. Or can also use PCl5, PCl3. Okay, alright. But for the product, just simply replace the OH with Cl. Siap. Okay. Right. Ta-da. Okay, macam mana? So far, okay ke? Nucleophilic substitution just now before we proceed to elimination.
Okay, madam.
Okay, madam.
Okay.
Madam.
Alright.
Yeah.
Okay, very good. Alhamdulillah. Okay, so you perasan tak? Dia macam lebih kurang alkyl halide. Dia ada substitution and also elimination. Okay, for alcohol. Okay, so elimination of alcohol is known as dehydration. Maksudnya dia nak buang air, nak remove air, nak remove water from the molecule. Okay, so bila dia buang water from the molecule, it will form alkenes. Betul tak? Yeah. Okay, it will form alkenes. Sama macam alkyl halide. Alkyl halide, kalau elimination of alkyl halide is known as dehydrohalogenation. Okay, dehydrohalogenation. Okay, so let's look at in terms of the remover of water. Okay, so dehydration of alcohol with sulfuric acid and heated, and should be heated. Okay, so this is also known as acid catalyzed, will produce alkene. Sama juga tadi, elimination of alkyl halide produce alkene juga. Okay, alright. So in order to produce alkene, dia akan follow the ZZ rule. Remember, ZZ akan cover the C double bond C as the product, and yield more stable alkene as the major product. Okay, so kat situ you dah ada understanding, you already understood on how the product is formed following the ZZ rule. Okay, so you just apply for alcohol je lah. So that is one good thing lah. So dia bukan something yang baru. Okay, so general reaction of dehydration is as follows. Okay, so dia akan attack. So acid catalyzed, dia sulfuric acid and heated. So dia H3O plus lah basically. Okay, so ni sebab dia nak provide this one. Okay, dia akan attack. This OH is nucleophilic. It will attack the hydrogen, one of the hydrogen for H2O plus. So this bond will be broken down. So both of the electron will be given back to oxygen. Okay. Alright. So now dia dah ada extra hydrogen pula dekat situ. Sebab dia ambil hydrogen ni tadi. Okay. So bila dia ada extra hydrogen dekat situ just now. So dia akan jadi plus pula dekat situ. Sebab one of the lone pair is used to form bond with the hydrogen just now. Okay, so this is considered unstable ataupun dia dah jadi electrophilic kat situ sebab dia dah ada positively charged. Okay, alright, so dia akan remove itself, okay, detach itself from the carbon. Okay, dia akan remove itself, maksudnya both of the electron, so ni akan break down. So both of the electron will be given to oxygen. Okay, will be given to oxygen. So then you have the carbocation. So dia jadi carbocation sebab dah keluar ni. Ni, the whole thing ni. Okay, dia depart from the molecule. So dia jadi carbocation. Okay, tapi interestingly, another H2O dia akan attack the adjacent carbon. Okay, dia bukan pergi attach itself to the carbocation. Bukan begitu. Nanti dia jadi alkohol balik. Okay, dia akan attack the adjacent carbon yang consists the hydrogen. So dia akan attack that one. So dia nak ambil this hydrogen. So this one will be broken. Okay, so both of the electron will be given to carbon, and that carbon will form double bond with the carbocation just now. Jadilah dia double bond. Okay, jadilah dia double bond di situ. So yang nak highlight kan, bila ada formation of carbocation, of course dia akan prefer tertiary over secondary, and lastly will be primary. Sangat tak prefer. Okay, so these are basically the steps of mechanism lah, the mechanism. Okay, to produce alkenes. So bila ada case macam ada dua option macam tu kan, nak ambil. So hydrogen ni, so this hydrogen can be removed. And imagine if this plus, you ada lagi satu carbon dekat sini. Betul tak? You ada satu carbon. So dia ada dua option kat situ. This H2O boleh attack this hydrogen and can also attack this hydrogen. Begitu. Okay, ini kebetulan dia carbocation, this carbocation is at the terminal. So dia akan pilih this hydrogen saja. Tapi kalau dia dekat tengah, this carbocation is located at the middle ataupun in between the two carbon. So dia ada dua option hydrogen dekat situ. So nak pilih mana? So double bond akan terbentuk di mana? Kita akan based on ZZ rule. Okay, right. Like this one. Okay, like this one. Okay, ni kalau you kembangkan ni, you ada H. Okay, ini jadi 2. This one you kembangkan, you ada lagi satu H. So dia ada satu H. So you ada 2 H yang you boleh extract out. Okay, so the first option is between this carbon and this one. Another option is here. Tapi yang mana as major? Okay, mana will be major? So you kena identify lah. Okay, the easiest way will be you determine this carbon is secondary, right? How about this carbon? This carbon is primary. So double bond akan prefers to form double bond. Double bond will be formed prefers to form at the secondary carbon. Yeah, because instead of here. So this is another option. Like I said just now. Okay, bila dia sengit-sengit tu nanti kan mulalah student macam pening kan. Tapi sebenarnya dia option dia dekat depan ni ataupun dekat belakang ni. Okay, so this will be the major lah, and this will be the minor. Kenapa dia minor? Because dia tak follow the ZEF rule. Right? Okay, so these are the condition that you have to remember. Okay, so it should be H2SO4 heated ataupun you can also represent as H3O+. Okay. Okay. Ini kita kena try lah. Okay, sebab tadi tu naming okay lagi. Okay, ini kita mungkin kena try. Okay, the following alcohol has been subjected to acid catalyzed dehydration and yields a mixture of two isomeric alkenes. Draw the two alkenes in each case and predict which one is the major product based on ZEF rule. Okay, you nak buat yang mana? A ke nak B?
Madam, B, madam.
B? Alamak, ada dua pula. A.
B.
Nak A ke B? Okay, A dah dua lawan satu, 2 versus 1. Okay. Lagi, the final one.
A.
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 Aduh.
A.
Okay, rasa A lagi banyak lah. So, kita sambung. Kita buat A lah Okay. Dia nak ni ke? Nak mechanism, of course lah. Dia tak. Okay, dia nak final product kan? One major, one minor kan? Okay. Alright, so first let's draw the structure first. Butanol, 1, 2, 3, 4. 1, 2, 3, 4. Okay, carbon number 2 we have OH. Carbon number 2 and 3 we have methyl group. Okay, so this is 2,3-dimethyl 2-butanol. Okay, undergoes reaction H2SO4 ataupun you nak pakai H3O+ pun boleh. Okay, heated. Okay, so bila kat sini you kena identify dulu. This is elimination reaction. Okay, nanti pelik-pelik lah. Tak ingat lah ini elimination terus buat dia substitution lah apa mengarut lah tu. So ini elimination reaction. Bila elimination reaction, so OH will be removed. So it will form double bond later on. Tapi isunya nak form double bond dekat mana? Ada dua option dekat situ. Because this is unsymmetrical alcohol. Unsymmetrical. Dia tak sama Kalau, unsymmetrical tu, symmetrical means like this. Kalau you lipat lah ataupun you belah dua, you akan produce the same side. It's like the mirror image. That will be symmetrical. But this one obviously is not symmetrical. It is unsymmetrical. Okay, so this is the carbon yang directly attached to OH. Kita kena identify the adjacent carbon. Kalau alkyl halide dia ada beta kan, beta hydrogen kan. This is almost the same. Okay, alright. So this one will be banyak benda ni. Sebab dia ada dekat sini satu. Dia ada 3. Okay, dia ada 3 jiran carbon dia, adjacent This one dengan this one. Okay, alright. So ada 2 probability. This one might be the same lah. Okay, alright. Pakai kali lain. So this one sebenarnya kita ada hydrogen. Betul tak? And this one pun ada, dia ada 3 hidrogen sebenarnya. So this one pun ada 3 hidrogen. This one kita ada 1 hidrogen. Okay. Dia ada 1 hidrogen. So mana yang dia prefer? Okay, kita nak tahu prefer yang mana. Kita identify dulu dia punya degree of carbon. So this one is primary. Right? This one also primary. Primary kan? Kan dia form carbocation just now. Sangat tak prefer primary. Okay? This one on the other hand is tertiary. Okay? Alright. So, obvious lah ni. Okay? So, maksudnya double bond akan form between this one. So, OH dengan this one will be kicked out, will be removed and it will form double bond here. So, that's the only option yang ada sekarang ni. Okay? Okay, in case everything the same. Apa ni tu? Begini. OH ni dah keluar kan? So dia akan form double bond dekat sini. Tada! Okay, siap dah lah. This is based on CHM rule. Ada tak major minor? No, this is the only product form, the sole product form. Because why? Dia versus primary versus dengan tertiary. So primary is very unstable. So it will not be formed at all. Unless you ada secondary dengan tertiary. So this one will be major. This one will be minor. Mungkin ni kot yang ada major minor tu. Okay. So this will be the answer lah for A. Draw. Okay. Has been subject to draw the 2 alkenes in each case. Pretty which one is the major product based on the CHM rule? Kalau dia go for primary just now, this will be the major kan? The other one will be here. So double bond we will have macam kuda pula. Okay. Alright, so we will have double bond here. Ataupun here lah, the other one. Okay. This will be the minor. But this one will not be formed lah. Sebab dia primary kan. Okay. Yeah. Kejap. Mine just now? Yep, sama. Okay, dia dekat tengah-tengah ni. Sama lah. This one not a problem. This one secondary dengan secondary. Okay, you ada tertiary. This one OH. Kan? So, dia either dekat sini ataupun here. Hydrogen. So, dia akan, of course, dia akan pilih yang ni as major. So, double bond akan dekat sini. Atau the other one dekat sini. Because why? Sini adalah secondary. This one is tertiary. So, of course, this one will be major. This one will be secondary. This will be minor lah. Okay? Okay. Moving on. Sekarang buat apa? Lama pun tambah. Okay, maybe we can finish up the oxidation, dia punya reaction dulu, okay? So later kita akan ada test to distinguish classes of alcohol, like what we have for alkene last time, okay? To detect the alkenes, yang kita pakai CHM096, okay? Bromine solution, so that one kita continue during our additional lecture. Okay, so let's finish off the reactions of involving alcohol. Okay, right. So this will be the last one for today lah. So alcohol can undergo oxidation. Okay, alcohol can undergo oxidation. So typical oxidizing agent are, so this one is the most common one. You tahu kan? Potassium permanganate. So other than this one, oxidizing agent, you also have potassium dichromate. As you can see, the number of oxygen supplied here can be supplied from this potassium dichromate is 7. Okay, so these two are considered very, very strong oxidizing agent. And it should be in acidic condition. Acidified. Okay, yang ni kena hafal sikit lah. Okay, so when you have primary alcohol and it undergoes oxidation, it will produce aldehyde or carboxylic acid. Okay, so it will produce alcohol. Primary alcohol will produce aldehyde ataupun sebab dia very strong, okay, dia akan directly oxidize to carboxylic acid sebab dia very strong oxidizing agent. Dia macam ni. Primary alcohol oxidize to aldehyde. Further oxidation will form carboxylic acid. Tapi since these two are very strong, dia akan oxidize this primary alcohol sangat ke carboxylic acid. Dia tak lalu pun aldehyde sebab dia too powerful. Okay? Okay. Next, secondary alcohol will be oxidized to ketones. Tertiary alcohol will not undergo oxidation. Kenapa? Okay, dia punya tips dia adalah, in order to undergo oxidation, you kena ada free hydrogen atom attached to that carbon yang pegang OH. Okay, like this one. Okay, this is primary alcohol. Contoh lah ya. So this is primary alcohol, right? Okay, so this carbon mesti kena pegang at least one hydrogen in order to undergo oxidation. So this is primary alcohol kan? So dia ada dua hydrogen there. So it can be oxidized. Same goes to secondary alcohol. So how do you draw secondary alcohol? So we have CH3, OH, okay, another CH3, and then hydrogen. So ni secondary kan, because this carbon is attached to two other carbons. So we have one oxidizable hydrogen. So this is what we call oxidizable hydrogen. So in order to be oxidized, the carbon need to be attached to at least one oxidizable hydrogen because this one will later be oxidized. Okay, so this is secondary. So dia ada at least satu. Kalau tertiary, masalah tertiary adalah dia carbon ni tidak ada, tidak attached to at least one hydrogen. Bukan cerita yang ni ini bukan carbon, ini kita kena direct to the carbon yang attached to OH. Bukan, ini orang lain punya ni. Kita mesti ada hydrogen attached to the carbon itu sendiri. So dia tak ada. So that's why dia tak boleh undergoes oxidation. Okay, ni baru dia nak keluarkan cakap dia kat situ. Saya dah beritahu dah, baru dia keluarkan. For oxidation of alcohol, there must be at least one atom hydrogen, or also known as oxidizable hydrogen, bonded to carbon atom containing the hydroxyl group. Okay, so that is why tertiary cannot be oxidized. Okay, so primary alcohol. So this is primary. Make sure dia primary kalau dia missing out apa ke, terlebih ke, beritahu saya. Okay, dia undergoes oxidation. Okay, dia akan oxidize into aldehyde. So this is aldehyde. So both of the apa nama ni? Sorry. Okay, right. So dia akan oxidize into aldehyde. Okay, this is only for primary alcohol into aldehyde. So this is aldehyde, nampak tak aldehyde? Okay, and then kalau further oxidize lagi, it will become carboxylic acid. Okay, secondary alcohol dia ada satu oxidizable hydrogen. Primary dia ada dua oxidizable hydrogen. Okay, so it still can be oxidized. So dia jadi ketone, Tertiary alcohol, on the other hand, there's no hydrogen attached to the carbon, so it cannot undergo oxidation. So there's nothing happen there. Okay, right. Okay, so like I said just now, kalau kita pakai KMNO4 and K2CR2O7 in acidic condition, so these two are very strong oxidizing agent. Strong as in apa? Maksud kuat tu apa? Maksudnya it is able to oxidize, okay. Katakanlah kita ada ethyl alcohol, kita ada primary alcohol, it is able to oxidize this directly to carboxylic acid. They skip this part. Sebab dia too powerful. Dia tak akan lalu this aldehyde. Okay, dia akan form the carboxylic acid directly. Okay, that's why they're very strong oxidizing agent. So, macam mana kalau kita nak stop dekat aldehyde? Tak naklah sampai carboxylic acid, nak stop sampai aldehyde je. Nak stop sampai sini, sampai this part. So what should we do? What can we do? Okay, so the option is to use this PCC. Okay, so this PCC is known as pyridinium chlorochromate, atau you can represent it as PCC. Okay, remember PICC? But this one without the I. Okay, you may use PCC. Understood, terus faham. Maksudnya PCC in dichloromethane is usually used in synthesizing aldehyde from primary alcohol. It will not further oxidize the aldehyde to carboxylic acid. Maksudnya dia akan stop dekat aldehyde saja. Sebab ini, this is what we call mild oxidizing agent. Potassium manganate and dichromate just now, dia strong oxidizing agent. Okay, so it is milder than chromic acid and can perform at lower temperature. So by using primary alcohol, using this PCC in this solvent, it will produce an aldehyde. Funny, aldehyde. Okay, so this is the option lah, the alternative. If we will go to, if we want to stop the reaction at aldehyde, then we will go for PCC. Okay, kalau you pakai KMNO4 ataupun potassium dichromate just now, you won't stop at aldehyde. You akan go from primary alcohol to carboxylic acid. Okay, sebab dia very strong. Yes. Okay, all right. So that is all for reactions of alcohol. So next we will have the tests, okay, to distinguish the classes of alcohol, to distinguish primary, secondary, tertiary. Macam mana kita nak distinguish these three alcohol? Contohnya dalam lab you have three unknown alcohol bottle. So how could you perform? How can you differentiate ataupun distinguish these three alcohols? So apa test yang you boleh pakai nak bezakan alkohol ni primary ke, secondary ke, tertiary? So these are the tests that we could use. Okay, alright. So this one will be covered during our additional lecture later. Ni ada berapa slide lagi ni? We have like 3 more slides to go. So 1, 2, 3, 4. 5 slides to go. Okay. All right. That is all for today's lecture. So dia agak heavy. Okay, saya tahu agak heavy. Halide dengan alcohol. So do not waste any time. Balik, make sure that you refresh everything. Okay. So the more you wait ataupun the longer you wait, lagi dia dissipate. Okay. Dia akan ni lah. Hilang lah nanti Alright, so do something about it. So dia memang agak heavy. I admit that it's very heavy. It's quite heavy compared to alkene last time. Alkene mungkin you berkobar-kobar semangat, tiba masuk alkohol je tadi berasap. Okay, awak berasap kepala, saya berasap mulut. Okay, alright. So don't give up. Okay guys, sikit je lagi. So we'll see you later during tutorial and also lecture. Okay, alright. See you. Thank you everyone. Bye-bye.
Thank you, madam.